Perfect, right? Now, let's look at the second thing that can happen. As it goes near the liver, half of IDL is taken up by the liver, and half of the IDL will be converted to LDL. And which enzyme does that? That will be your hepatic lipase. So, your hepatic lipase converts ILDL into LDL. And then LDL will again be taken up by the liver. But this time, the key difference is IDL is the remnant recognized by ApoE receptors. LDL will be recognized by what? Receptors that recognize ApoB100. So, LDL has ApoB100. Those receptors that take up LDL, for example, when we give statins, right, to people, you lower the cholesterol, you upregulate your LDL receptors. Those receptors look for molecules that have ApoB100 on them. That will be your LDL, okay? So, ApoB100. So, we just discussed chylomicrons, we discussed VLDL, we discussed how they interact with HDL. Now, let's do a little bit about what HDL does, because that's also very important. HDL, as we mentioned earlier, or I think I haven't mentioned that yet, but HDL is a reverse cholesterol transporter. Okay? Its job is to take cholesterol from cells or from anywhere, even from oxidized macrophages or any place it can, and it's going to transport it back. So, when HDL enters the blood, it's going to interact with cells. Let's say any cell, right? So let's say this is the cell membrane. This is your outer, this is your inner, and this is our HDL. First thing is first, we need cholesterol to go from the inner membrane to the outer, right? So this is our cholesterol. Which enzyme or which protein facilitates that? Those are going to be your ABCA1 transporters. Keep that in mind. It's simple recall. It always comes. So this process is done by your ABCA1 transporters. Now, HDL has phosphatidylcholine inside them, PC. We also call that lecithin, or that's how I pronounce it. Cholesterol and PC are going to combine and form cholesterol esters. And there is one enzyme that does that. So, ABCA1 transporters push cholesterol from the inner membrane to the outer. Then cholesterol combines with phosphatidylcholine, which comes from HDL, to make cholesterol esters. The enzyme that does that is LCAT. Do not confuse this with ACAT. ACAT acts intracellularly. LCAT, on the other hand, acts extracellularly. It's going to activate work outside the cell. And the main thing, right? Everything has a purpose, as we mentioned. ApoB48 is needed by chylomicrons. ApoB100 is needed by the VLDL. It's also recognized by your receptors that recognize LDL. ApoE is recognized by remnant receptors. ApoC2 activates LPL. ApoC3 inhibits LPL. What about ApoA1? ApoA1 has a very important function. ApoA1 is going to activate your LCAT. That's the main thing. Activated by ApoA1. Once this happens, this entire process happens, this converts HDL into HDL3. Alright, so at this point, there should be no confusion. At this point, LCAT activates, takes the cholesterol that was on the outer membrane, which was brought by your ABCA1 transporters from the inner membrane, fuses with phosphatidylcholine, become cholesterol esters. This is done by LCAT, which is activated by your ApoA1, converts your HDL into HDL3. Now, a funny thing happens. Your HDL3 will interact with VLDL because that wants to get rid of its cholesterol esters and it needs tags, right? So that's what it does basically. So, what is VLDL giving HDL3? It gives it tags. And what is HDL3 giving VLDL? Cholesterol esters. This process is facilitated by a protein called CETP, which stands for cholesterol ester transfer protein. I think I said that right, hopefully. CETP. Once this is done, this will convert your HDL3 into HDL2. Now, as we remember, HDL2 is taken up by the liver. So, if this is the liver, we have the receptors here. Which receptors have which domains on them that recognize HDL2? Those are your SRB1. Keep that in mind. SRB1. Okay? It's gonna go in. Your HDL2 will be cracked open in the liver, and there's gonna be a certain enzyme inside that's gonna cleave the tags off of HDL. That enzyme will again be your hepatic lipase. Hepatic lipase will come in once HDL is anchored on the membrane of the liver because it's recognized by SRB1 receptors, right? Your hepatic lipase is going to come in, crack open your HDL2, get the tags, and then convert HDL2 back into HDL3. So, once this happens over here, this will be converted back into HDL3 by your hepatic lipase, right? So basically this is the overview of lipoproteins. Now one thing keep in mind is you have a certain disease, and that's going to be a hypolipidemia, that you will not produce VLDL or your chylomicrons because there's a certain protein that's deficient, and its job is to recognize ApoB48 and ApoB100, and that is your MTP, microsomal transfer protein. Keep that in mind as well. I will write that here. MTP, its function is to recognize ApoB48 and ApoB100. Okay? Second thing, you have SRB1, right? Those receptors recognize HDL2. You have something called SRA receptors. SRA receptors, on the other hand, are found on macrophages. I repeat, they are found on macrophages, and their job is to phagocytose oxidized LDL. Okay? So that's about it, right? And if there's any confusion, keep watching this or look back at the lecture slides, and hopefully I hope this helped, right? So enjoy.